Okay, so as in the last video, we have done introduction to the theories of the covalent bond. We said that there are not five, however, four theories of covalent bond. The first one includes Levi-Strauss structure or electron dot structure. Second, BBD or valence bond theory. Third, VSEPR, valence and electron pair repulsion theory. Last but not the least, MOT, molecular orbital theory. In today's video, we are going to discuss in very detail the Levi-Strauss structure, or you can say Levi-Strauss theory or electron dot structure, right? In today's video, we are gonna just have an introduction to the Levi-Strauss structure, but by the next video, we are gonna deep dive into it, and we actually gonna make the structures according to the Levi-Strauss theory. Okay, so today we are going with an introduction to the Levi-Strauss structure. Introduction to the Levi-Strauss theory, structure, or electron dot theory. Electron dot structure. Electron dot structure. Okay, so we will have an introduction to the Levi-Strauss theory or Levi-Strauss structure or electron dot structure. Okay, so why do we use this theory? Since this theory is used to, fill the octet rule. But initially, we need to understand that we need to select a central atom. All right, if we have HCl, so what would be the central atom in it? All right, we need to identify that. If we have HF2, okay, so what would be central atom in it? Not HF2, however. Okay, so we initially need to identify the central atom first, right? Central atom. Now, how we're gonna select a central atom, right? We will be selecting the central atom, or the central atom in the compound will be that who will be less in number, initially less in number. If not, if there are equal ratio, for example HCl has an equal ratio, right? You cannot identify now on the number of the atoms, then you may go towards electronegativity. That must be least in electronegativity. Least in electronegativity. Least in electronegativity. All right, if you cannot identify through least in negativity, then actually you can jump towards another factor. Then you can go with an atom which has highest atomic number. Atomic number, right? Now see how you will be selecting a central atom. You will be selecting the central atom on the basis of its number in the compound. If there would be equal ratio of the atoms in a compound, then you will leave this factor and you will move towards least in electronegativity. That the central atom you are going to choose must be least in electronegativity, and if not that is least in negativity, which means if there is a compound and they don't have electronegativity difference, then you may go towards another factor, and that is highest atomic number. So the one which will have highest atomic number, that would be your central atom. Now, which atoms cannot be your central atom? Let's discuss that. See, there are two atoms which cannot be your central atom. The first one, hydrogen, and the second one, fluorine. These are only two atoms which cannot be your central atom. I must write here cannot be central atom, right? Cannot be central atoms. So hydrogen and fluoride cannot be central atoms at all. Thirdly, central atom can break the octet rule. Central atom can break an octet rule. An octet rule. So central atom can break the octet rule, but side atoms cannot. But side atoms cannot break. Cannot break octet rule. So central atom can break the octet rule. However, side atoms can never break octet rule. We have a factor of maximum covalency as well, but here I'll not discuss that. That I'll discuss when we are gonna make the structures by using Levi-Strauss theory. So what we have discussed actually today is all about choosing the central atom. We know that we need to choose the central atom. Since if you have, I wrote here, right, HCl, or you can write here any other one, for example H2SO4 or S2. Alright, if you have this, so initially you need to choose the central atom. Now here you can see what can be the central atom. Of course this sulfur will be the central atom, since we have already discussed less in number. So sulfur is less in number. Oxygen, we have two atoms of oxygen here, so sulfur is only one. So basically here sulfur would be the central atom. Now where these oxygen can be placed? Okay, so second rule we discuss, hydrogen and fluorine can never be central atom. They can never be actually central atom. Okay, oxygen can be central atom, sulfur can be central atom, uh, chlorine can be central atom, carbon can be central atom, and most of the cases you're gonna have chlorine as a central atom. But yes, you will not gonna find hydrogen and fluorine as central atoms. Thirdly, central atom can break their octet rule, but the atoms which will be on the side of that can never break the octet rule. Now see here, the sulfur can break the octet rule. However, oxygen will be on the side of it, and it can never actually break the octet rule. Now we're gonna, in the next video we're gonna make a lot of structures by using this Levi-Strauss theory, and we will gonna make every structure in very detail by a trick. Of course, we'll not gonna have a very big process for it, but yeah, we'll gonna have trick for it, so that we can actually very easily make the structures by using Levis dot structure.